This is the lightest solid that has ever existed. It is 99.8% air. And yet this fragile little block once caught a piece of a comet moving 6 times faster than a bullet, and it can stand in front of a blowtorch and protect a flower behind it. They call it frozen smoke. Hold a piece the size of your fist, and you would swear your hand was empty. There's almost nothing here. It is so light that a gentle breath can push it across a table, and if you dropped it, it would drift down like a snowflake. The material is called aerogel, and almost everything about it sounds like a lie. A normal block of it is 99% air, held together by a skeleton of glass, so thin you can barely see it. It is a solid you can look right through. How light is that? Really? Quick, guess the weight of a fist-sized block. A brick? A foam? The lightest aerogel weighs about 3 milligrams for every cubic centimeter. Air weighs about 1. So this solid is only a whisker heavier than the empty air it replaced. Scientists nicknamed it frozen smoke because that is exactly what it looks like, a wisp of blue smoke frozen in place that somehow you can pick up and hold. Some aerogels are so light that if you pump the air out of them, they would weigh less than the air itself. And it feels as strange as it looks. Press it, and it is dry and oddly warm to the touch because it refuses to pull the heat out of your skin the way glass or metal would. Your fingers keep their warmth. It is like touching a solid piece of silence. So where did something this strange come from? The story starts in 1931 with a bet. A young American scientist named Samuel Kistler made a wager with his friend Charles Learned, and the challenge sounded almost silly. Inside a jar of ordinary jelly hides a secret. Jelly is not really solid at all. It is a delicate sponge of solid strands, and every tiny hole in that sponge is filled with liquid. It looks solid, but it is mostly water in a trap. Kistler's challenge was this. Could you pull all the liquid out of that sponge and replace it with air without the whole thing collapsing into a pile of dust? Everyone he told assumed it was flat out impossible. To even try, he first had to grow the sponge itself, mix the right chemicals, and they knit together into a wet, jiggly gel, a bit like clear jelly laced through with liquid. That gel is the starting point. Now came the impossible part, emptying it without wrecking it. And here is why they doubted him. If you just let a jelly dry out on the counter, it shrivels up like a raisin. As the liquid escapes, it drags the fragile walls inward and crushes them. The whole sponge caves in on itself. But Kistler had a clever idea. The problem, he realized, was not the liquid leaving. The problem was the surface, that sharp border between liquid and gas, which pulls on the walls like a million tiny rubber bands. So what if you could erase that border completely? So he did something bold. He put the gel inside a sealed pressure chamber and cranked up the heat and pressure together. Push a liquid past a special point, and the liquid and the gas stop being two different things. They blur into a single state, with no surface left at all. Now, with no surface to pull anything apart, he let the fluid slip out gently, molecule by molecule. And when it was gone, the fragile skeleton was still standing, perfectly intact. Kistler had won his bet. He had just made the first aerogel in history. Today we do it with liquid carbon dioxide instead of flammable alcohol, which is far safer. But the trick is exactly the one Kistler discovered almost 100 years ago. Dry the gel without ever letting it feel the deadly pull of a surface. What you're left with is astonishing. A solid that is up to 99.8% empty space and less than 1% actual glass. It is mostly a ghost. And here's a number that breaks people's brains. Unfold all the microscopic surfaces hidden inside a single gram of aerogel and spread them out flat. They would cover an entire soccer field. One little pinch of this stuff has more inner surface than a whole stadium. Now look closer and you notice something beautiful. Against a dark background, the aerogel glows a soft blue. But hold it up to a bright light and it turns warm, almost golden. Why would the same object be two different colors? To answer that, look up at the sky right now. The sky is blue for one simple reason. The tiny molecules in the air scatter blue light in every direction, while letting the warmer colors sail straight through toward your eye. Aerogel does the exact same thing. Its skeleton is so unbelievably fine that it scatters blue light, just like the sky, and lets the golden light pass through. When you hold a piece up, you're literally holding a tiny square of sky in your hand. And that warm glow you see shining through it, that is the very same reason sunsets turn red. The blue has been scattered away on its long journey, and only the warm light survives to reach your eye. Sky and sunset in a single block. But the real magic, the thing that made NASA fall in love with it, is what happens with heat. Take a flower, a crayon, even a piece of chocolate, and put a thin slab of aerogel in front of it. Now, aim a blowtorch, burning it over 1,000 degrees, straight at the other side. The flame roars, the front glows red hot, and just a centimeter away, the chocolate does not even begin to melt. You could rest your bare hand on the cool side. Stop and picture that for a second. Fire on one side, your fingertips on the other, and almost no heat gets across. Feel your own hands right now. That warmth is heat trying to escape. Aerogel would stop it cold. It is the best insulator solid matter has ever produced. The secret, once again, is all that trapped air. Heat normally travels by hitching a ride on moving molecules bumping into each other. But inside aerogel, the air is locked in a maze of holes, so tiny the molecules can barely twitch, let alone move. So heat is forced to crawl along that thin, twisting glass skeleton, taking the longest, most exhausting path imaginable. By the time it finally staggers out the far side, it has almost nothing left to give. Watch how fast it drains away. Point a thermal camera at it, and the proof is undeniable. One face blazes white hot, the other stays a cool, calm blue right next to it. To a heat camera, aerogel looks like a wall between two completely different worlds. Because of tricks like these, aerogel has broken record after record. For years, it held the Guinness title as the lightest solid on the entire planet. And even today, it still holds around 15 separate world records for its material properties. It has since lost the crown for lightest material to even stranger cousins, built from graphite and graphene, that can rest on a single flower without bending a petal. But for holding back heat, plain silica aerogel is still one of the finest things we have ever made. Which brings us all the way back to that comet from the very beginning. In 1999, NASA launched a spacecraft called Stardust on a genuinely wild mission to fly straight through the tail of a comet and catch some of its dust to bring home. But there was a huge problem. Those specks of comet dust were flying at about 6 kilometers every second, 6 times faster than a rifle bullet. Try to catch them with anything solid, and they would simply vaporize the instant they hit. So NASA filled a tray with aerogel and held it out into space like a catcher's mitt. When a dust grain slammed into it, the fluffy, almost empty material slowed the grain down gently, over a long distance, instead of stopping it all at once. Each tiny particle carved a long, carrot-shaped tunnel into the aerogel, up to 200 times its own length, and finally came to rest, completely unharmed. Scientists could peer into the clear block and follow each track straight down to the grain at the tip. In 2006, that little capsule parachuted back down into the Utah desert, carrying the first samples of a comet ever brought to Earth. Thousands of grains of dust, older than the sun itself, all caught safely by a block of frozen smoke. And those grains rewrote the textbooks. Inside them, scientists found minerals that could only have formed in blistering heat, right next to a young star, somehow flung all the way out to the frozen edge of the solar system. Frozen smoke handed us a message from before the Earth was born. Aerogel went to Mars, too. It wrapped the delicate electronics of the Mars rovers in a blanket thinner than your finger, keeping them alive through freezing Martian nights that plunge far, far below anything on Earth. And back on Earth, engineers are now stuffing it into jackets, windows, and pipelines. A single layer, just a few millimeters thick, can insulate, as well as a thick wall of ordinary foam. Explorers have even worn it to the top of Everest. So aerogel sounds like the perfect miracle material. Lightest, best insulator, catcher of comets. But there is a catch, and it is a big one. If it is this incredible, why isn't your house already wrapped in it? For all its strength against heat, classic aerogel is painfully brittle. It can hold thousands of times its own weight pressing down from above, and yet a careless pinch from the side will shatter it like a dry cracker into blue dust. That fragility is the #1 reason your walls aren't already full of it. But labs around the world are now brewing flexible, rubbery aerogels that bend instead of breaking. And with every passing year, the price quietly keeps falling. Picture this. Climbers have already stood on the roof of the world in temperatures that freeze skin in seconds, wrapped in jackets barely thicker than a hoodie, lined with a whisper of aerogel. The same material that shields a spacecraft can quietly keep a person alive on Everest. So think about what this material really is. It is almost entirely nothing. Empty space, given a shape you can hold. A solid made, more than anything, out of the absence of solid. And yet that whisper of nothing can catch a comet, hold back fire, and carry a piece of the sky in the palm of your hand. Sometimes the most powerful thing in a room is the one that is barely even there. If this amazed you, there is a whole universe of it right here on the channel. I'll see you in the next one.